Hey everyone, this is Daniel for Rock the JVM, and today I bring you another master programmer that you can learn from. And today my guest is Paul Snively. He is a software architect and engineer with more than 4 decades of programming experience, and he's seen it all. He's worked professionally with a variety of programming languages and tools and mental models, including C, Java, Lisp, Haskell, Scala, of course, and many others. And he's also held a variety of technical positions at big names in the industry, including Apple, Intel, Verizon, VMware, and many others. He's also a frequent conference speaker around the world, and he talks about functional programming and formal verification and reliable software in general, all of which are topics that we cover in this conversation. And we cover a lot. We cover programming languages and tools and which ones you should use and which ones you should learn, especially in this day and age, or if you're coming new in the industry, how to develop good mental models and good, reliable software, and how to develop good taste, which is a very interesting topic because when you hear somebody talking about how they intuitively developed good taste after enough time spent in this industry, you know you're talking to a master, and Paul is definitely a master of this craft, and I believe he's far less famous than he should be, which is my attempt at making him a little bit better known in the industry. So please enjoy a wide-ranging conversation with a master of software engineering, Paul Snively. Paul, thank you so much for coming. It's good to see you.
It's good to see you. Thanks for asking.
All right, so I wanted to start with a little more general question, and then we can dive deeper as we go along. So I wanted to ask, I mean, you've seen it all. You have more than 4 decades of programming experience, and you've seen a lot of languages, a lot of tools and stuff. Do we still need to learn programming languages in this day and age?
Well, that's a really great question. Given my personal preferences and prejudices and all that, of course, you can anticipate that I'm going to say yes. It's interesting, though, because I do think over these decades, we've seen a kind of contraction and expansion of programming languages that are actually being used. So for a while there, it seemed like it was all, if you were doing systems programming, it was C or C++. Everything else in the enterprise was probably Java, starting around 1995. And then, nimble startups were doing PHP or Ruby on Rails or something like that. And so there seemed to be this rather clear and rather small kind of collection of languages that were considered fit for purpose for very particular kinds of uses. Again, startups versus enterprise, that sort of thing, systems programming. But then I think we started to see, especially, of course, with the introduction of Scala on the JVM, and then later with Rust in the systems programming domain. Well, actually, prior to Rust, Go, of course. We started to see some return to exploration, if you will, about what are some of the problems that developers encounter with the mainstream popular languages of the day. And some organizations took it upon themselves to say, well, let's really explore that question by developing a new language. And so here we are now with Go, Rust, several others that are maybe a little bit less even mainstream than those. How many JVM languages do we have now, right? We have Scala
Quite a
and
few, yeah.
Kotlin. Yeah, and then other, again, less mainstream choices than those. So I think it's interesting. I think we can say that not only for those of us who are interested in the theoretical side, but even in industry, there's been a little bit more acceptance that the languages that were obvious to use 15, 20 years ago are not necessarily quite so obvious, and that there are more choices. And there are good business reasons to have those choices. Rust obviously came out of Mozilla. Go came out of Google. So it's not even academia necessarily that's driving the Scala came out of academia, but we see more companies taking it upon themselves to say, we have a set of problems here that the mainstream languages are not serving us adequately in solving. And so now there are more choices. And I think once there are more choices that have corporate backing, there's greater freedom for an individual developer or a new founder of a new company to say, let's try something different. Let's maybe use something that not everybody else is using.
Is that still the case? Languages like Scala, I'm familiar with the history of Scala a little bit more, and there was this tendency, like 10 years ago maybe, for new companies to make a solid bet on Scala. For example,
Mhm.
Twitter, when they were like 15 engineers or 20 engineers, they made a bet
Right.
to start writing their entire infrastructure and their entire distributed system on Scala. A couple of
Mhm.
PhD students, Matej Zaharia and Jon Stojka, they founded Databricks basically on the back of Apache Spark. So
Right.
there was this bet on less popular languages, and Scala was definitely a less popular language back then. Is that
Mhm.
still the case that companies still make bets on less popular languages, or are they entrenching themselves to more popular languages like TypeScript and Python and Java and stuff like
Yeah.
that?
Yeah. So I think there's sort of two forks
Hmm.
to that question. So on one hand, I observed that some companies have taken it upon themselves to create languages to use, right? And then there's the parallel question of, are companies not necessarily developing their own languages and then introducing them to the world,
Hmm.
but making big bets on other languages that other people have developed. I think there has been, especially in the financial circumstances brought on by the pandemic, and with some other related kinds of questions like what the Fed started doing with interest rates and the reclassification of bookkeeping and accounting around software development expenditures as R&D expenditures. I think the industry has gone through a little bit of a more conservative swing. I think there's a little bit more emphasis on predictability of technology choices. Um, we don't have zero interest rates anymore.
Yeah.
So that's made organizations a little bit more risk averse with respect to their spending, understandably. But I do think that has a downstream effect on what I guess I'll call your innovation budget. A lot of organizations, I think, are pulling back. Also, I think there's a question of, if we decide we're going to bet heavily on a sophisticated language and a sophisticated ecosystem like Scala's, I think there's always been a question of hiring for that ecosystem. And then once you've hired staff for that ecosystem, um, what else do you have to do in order to make effective use of them? One thing that I think I've overlooked, frankly, for a lot of my career is the cost of consistency, maintaining consistency in a code base. When you have a tool set that gives you a lot of abstraction capability, a high abstraction ceiling, as I like to put it, now you have to spend a certain amount of time and energy making sure that ecosystem is used in a consistent fashion in your organization. And some organizations, I think, are averse to that. They don't want to put the time and energy into managing their development teams in such a way as to get a consistent artifact out of the team. They want a consistent artifact by default, if you will.
Yeah.
I think that's one of the reasons that Go became popular. You can get a team working very quickly in Go. It doesn't have a very high abstraction ceiling. Has great tooling, great build tooling, great debugging tooling, great Linux API access. So you tend to get consistent results quickly. I think that's a huge value proposition for a lot of organizations. So I'm a lot more sympathetic to to organizations choosing Go than I used to be, frankly. But I think I know why they're doing it. But I personally still think there's a lot of value in supporting a team using more powerful tools, more expressively powerful tools. I don't want to, my goal is not to insult Go. But rather, it's at one end of a spectrum of expressive power, and then something like Scala or Haskell or what have you is at a very different end of an expressive power spectrum.
How have you seen a language like I mean you have a decade of experience in Scala and uh, you've seen a lot. How have you seen? Do you have any examples of Scala being used very productively and the power of Scala being used well?
Hmm. Yeah, well, yes. I think probably, certainly my best professional experience, as I think about it as a personal satisfaction matter, I
Hmm.
suppose, but also in terms of the quality of the result. Those are parallel observations, I think. Um, Goes back to when I had the great honor and pleasure of working with Intel Media, which was acquired by Verizon Labs, and got to work with Runar Bjarnason and Paul Chiasano and Daniel Spivak,
Yeah,
and basically
the
this list of names that
the
everybody in the
heroes
Scala
of the
community
red
knows.
books and stuff. Yeah.
Right,
Hmm.
right. So that was interesting because it was a good example of what I hope for in an organization, which is to have a bunch of colleagues who are all very, very motivated by the same things and have a high degree of, for lack of a better term, taste. And so, again, going back to that observation about consistency of artifact, um, we worked on some very big systems for Intel Media and Verizon Labs. Unfortunately, the product that this was all oriented towards did not successfully launch into the market. But we got to open source some of the infrastructure work that we did. I'm thinking in particular of the knobs configuration system and the funnel distributed monitoring system. Funnel was a great piece of work. Architecturally, it wound up being almost identical to Prometheus, which was kind of the problem.
Interesting.
Prometheus came out at about the same time
Yeah,
as
they took
we did,
market share. Yeah.
and yeah, exactly, and won in the marketplace, and rightly so. I have to say, and no ill will to the Prometheus developers at all. But when I look back at our work on knobs and funnel in particular, I think those are really good examples of the kind of work that is possible with the kind of team that I hope a Scala using organization would assemble. Um, HTTP4S is probably my favorite Scala library on the face of the planet. It's just so well architected, and what I mean by that is there's a simplicity of concept to it. What is an HTTP service? It's a potentially effectful, potentially failing function from a request to a response. And that's exactly how it's modeled in HTTP for us. It's a Kleisli from a request to an option of response. And it's like, okay, if you have any idea what those terms mean, then it's obvious. Maybe that's the hurdle, and the documentation even says so. If you don't know what a Kleisli is, don't worry.
Can you explain for people what a Kleisli is?
It's funny because it's the place that I think we should start when we talk about functional programming. Why is that? Because the Kleisli is really just a wrapper around a monadic function. Okay, so there's another scary word
Okay, yeah,
already.
we're gonna scare people off with the monads or monoids in the category of empto
Yeah,
functors
category
kind of
of
stuff. Yeah.
functors. Yeah, right. So let's extract the word monadic from there. Um, so a Kleisli is a potentially fallible, potentially effectful function. So if you look at the signature in Scala in cats, for example, it's literally a wrapper around an A to M of B where M has some other type class instance, right? What can that type class instance be? Well, in particular, it can be monad. In particular, it can be monad error. So given an A, you can potentially produce a B and do, something, launch the missiles, not return a result at all, fail, right? All those things are modeled by Kleisli. And what's interesting about that to me is that's what most developers think a function is, period.
Intuitively, rather. So
Right,
when you look at the type signature of a function, when you originally learn about functions, when you're a beginner and you learn
right,
about functional programming and you learn about this concept of a function as a value and you pass that function
right,
as a parameter to another function and return functions as
right,
results and stuff, You tend to think of functions as A to B. That's
Yeah.
easy enough. Okay.
Right.
But then those functions A to B may produce other than the B. They may throw an
Right.
error, or they may produce
Right.
other things, or something else
Right.
may happen in the world rather
Yeah.
than just returning that value. And so
Yep.
you need a type that can abstract that, which is
Yes.
why you get this sort of generalizable function A to something of B. And that something can describe a computation that can return a pure value, can throw an
Right.
error, can produce
Right.
some sort of other phenomena
Yep.
in the world,
Yeah.
which we
Yeah.
generally call
Exactly.
side effects.
Right.
And that is, my friends, the definition of a Kleisli. This is
Right.
I'm speaking for people now that are scared of these very um, contrived terms in functional programming
Yeah.
with monads and monoids and endofunctors and Kleislis and
Right.
whatever. They get scared
Right.
about these concepts. And other functional programmers tend to reply with, "Oh, it's not that hard. It's just a Kleisli, or it's just a monad and a
Right.
monoid in the category of endofunctors. What's wrong with that?"
Guilty as charged.
I am guilty as charged as well, and I try to, in my teaching, I try to tone down this
Yep.
tendency as much
Yep.
as I possibly can,
Right. Right.
because it is part of my job to meet people where they are and
Yeah.
help them understand or step up in understanding
Yeah.
from where they are. And a
Yes.
Kleisli is just a generalizable function A to M of B, rather. That's
Right.
what a Kleisli
Right.
is. And an
Right.
HTTP server is a function from request to a response initially. But when you
Hmm.
consider that the fact that that response is produced asynchronously, or it may fail, or it may produce other things in the world, you want to
Yep.
abstract that. You want to pull that into a type. And so you get a request to something of response. And that
Right.
something is a monad error, a monad cancel, a concurrent, a sync, a spawn, or whatever else.
Right. Exactly. Yeah. Yeah. I think the message, if there's one message I want to convey to developers facing this sort of scary ecosystem with all these crazy names is, yeah, the names are crazy. Um, Kleisli happens to be a proper name. It's literally a mathematician's name.
Mm-hmm.
That's all. So it's interesting to me. It may not be interesting to a particular developer, but it's interesting to me that there was this group of mathematicians who figured out a lot of the stuff that we do in functional programming 100 years ago. Maybe not even in the context of computation. They had no idea that they were laying the foundation for this kind of approach to computing or approach to
It
programming.
was just math.
Yeah, it's all math. But we're stuck with these terms. We're stuck with terms like monad. We're stuck with terms like semigroup. We're stuck with terms like monoid. And the reason for that is because we're using those terms the way the mathematicians did to talk about algebraic relationships. Those algebraic relationships are important, but you don't necessarily have to have them memorized. You can take advantage of the language and the libraries and the APIs and all that kind of stuff, and basically just trust that the algebraic laws are over here to one side helping you. But you don't have to have them memorized, and you don't have to know what these names mean.
Why are these ideas, these math terms, or functional programming in general as a bubble that comprises all of these ideas, why are these important?
Yeah, that's a really great question. Something I've really started saying explicitly in a lot of contexts these days is there is a very specific reason to do purely functional programming. And that is that the entire model is all expressions all the time. And the way your program works is by those expressions, the technical term is reduction,
Mm-hmm.
those expressions being reduced to a simpler and simpler and simpler and simpler form until they're just the resulting value. We
Mm-hmm.
all know how this works. We all know from school that 2 plus 2 reduces to 4,
Yep.
right? Um, all functional programming says is do that for everything. So back to functions being values and A to M of B, one of the things we're doing there kind of quietly under the covers, so to speak, is first of all, we're turning effects into values. That's really what managed effects mean, is that instead of something happening because we sort of beat the computer into doing it, we're saying this becomes another value, this effect becomes another value, this error becomes a value. Now it's a value, so it becomes part of an expression that we can simplify. And there are laws, again, these algebraic laws about what we mean by simplify, what we mean by reducing some expression to a simpler expression until we're done, until the program has run and all these managed effects have happened, all that sort of thing. But ultimately, it's about that. It's about having a very simple mental model where you have a big expression and at the end you have a small expression. And in the course of making that small expression, you've printed something to the display, or you've made a network request to some other service, or these effects have happened. And if they failed, then this error has surfaced as a value. And once again, as part of some algebra, you can decide how you're going to deal with that error that's happened.
And where do you have any examples of use cases or domains where functional programming is particularly well suited compared to other styles or other ways of thinking about code?
Well, I'm glad you said ways of thinking, because I think that answers the question already. Um, if we want to know what our code is going to do before we run it, and by the way, that's another headline goal that I suppose I try to advance. How did we get ourselves into a world in which a programmer writes code and the only way they can know what it's going to do is to run it, is to try it. So yes, I do think functional programming is, again, value-laden word, superior, right? Because it's easier to know what functional programming code is going to do before it runs, precisely because you can look at an expression and you can say, okay, this is ultimately going to reduce in this way to a simpler expression. And in that process, it's going to do X, Y, or Z. That's the ball game, as far as I'm concerned.
And where is it important to? I mean, I guess the question is badly phrased. I wanted to ask, where is it important to know what the program is going to do before you run it? But the ideal answer is everywhere.
Everywhere.
Is there um, um, is there a domain or an example where you would not agree to using anything else other than functional programming
Yeah,
for this reason?
finance.
Finance, okay.
Yeah, finance, medical records. Um, you know, when I say software is becoming increasingly important in increasingly important domains, those are sort of obvious examples. Various people in a particular corner of the industry, especially, started to think about these things when they started to think about cryptocurrencies and smart contracts and those kinds of things. In fact, I would say the biggest push I see towards formal verification in software really attaches to the cryptocurrency and smart contract world. Set aside the fact that there are a lot of scams in that
Yeah.
world, right? That's obviously true, which is a problem. But there's this little subculture, sub-community off to one side here that really is trying to use. I mean, what's the headline goal of smart contracts, right? It's to allow collaborative computation among mutually distrustful counterparties, right?
And save
The idea,
programmable money, really.
yeah, the idea is that you don't have to trust the entity that you're engaged in some sort of transaction with on the other side of some interaction, whether it's monetary or something more tangential. That's, I think, an important goal. Whether what we now know of as cryptocurrencies and smart contracts are able to fulfill all those instantiations or versions or expressions of that goal is another question. But there are particular organizations that are very much engaged in trying to assure that that your smart contract is not going to fail catastrophically. It's not going to do you financial harm or you know put you out of business or some other catastrophic outcome. Similar thoughts apply to medical records, right? Obviously, privacy is just a huge concern with medical records in particular,
Mhm.
and ways to compute such that you can have a very large, multiple institutions, multiple healthcare providers, record keepers, government entities, regulatory bodies, all those kinds of entities able to interact in order to fulfill all the goals of modern healthcare, while not exposing very sensitive patient information, is another area where, boy, I really want people involved who care about correctness and reliability and privacy.
Yeah. So, in one word, that would be the important domains and the important software should be written in this style, where you would want to verify that the code will work before you actually start putting it to work.
Automotive braking systems,
Yeah.
avionics, you
I
know,
really wouldn't want a plane running Python, really.
right? So we start to see how there are big domains, B2C e-commerce. We're all blessed, I think, to live in a context in which we can engage in financial transactions online, consumer transactions with our credit cards, and we're protected by our credit card company, right?
Hmm.
Chargebacks, returns, all those things are basically well in hand, and were well in hand long before Amazon or any organization like that ever launched, right? We've been able to return things to the store and get a refund and things like that. So I think there's this world, which is very low risk for consumers and individual users. And then there are these other worlds that we just talked about, the avionics and medical instruments, medical records, those kinds of things, automotive braking systems, where catastrophic failure can mean somebody dies. And all of that is encompassed under the software umbrella. I think it's important to think about that. I think it's important to think about, and in your conversation with my good friend James Ward, you touched on this too. How do we make it easier? How do we make it less costly? How do we lower the entry bar to writing reliable software? I think that's the question
Do
that's
you have
really.
any idea how to do that? And the reason I'm asking is because one of the goals of Rock the JVM, of my learning platform, is to lower the learning bar and
Mhm.
make it easy for people to get to that level where they can write code using these concepts, which have historically been regarded as having a very high, a tall, steep learning curve. So I
Right.
wanted to flatten that learning curve as much as I could.
Mhm.
Do you have any other idea other than education, like
Right.
formal courses or formal structured
Mhm.
learning,
Mhm.
how to flatten that learning bar for people so that they can exceed to the level where they can write reliable software with these concepts, with effects,
Mhm.
with functional programming, with these math terms that provably demonstrate that the code is going to work.
Right. Yeah. It's tough. I don't know of a substitute for education, but can we provide technology that doesn't have quite such a steep learning curve, but nevertheless delivers the results we hope for? And Scala, I have to say, is turning out to be a really important test bed in that regard, as you know better than most people, I think, because you've had contact obviously with the type level ecosystem and the Zio ecosystem,
Hmm.
for example. And I would say, and I hope John DeGoes would agree, that one of Zio's major goals is that, right, is to say, never mind these scary names, never mind these algebraic structures. Haskell uses them, Katz uses them, nothing wrong with them, other than that they present this really steep on ramp. So I do think it's more incumbent on language designers and library designers to say, gosh, what can I do? I think syntax is an underappreciated concern as a matter of language design. Um, an example I like to offer is I like OCaml as a
Hmm.
programming language quite a bit. There's another language called ReasonML. And if you go to the ReasonML GitHub page, you can see a huge list of adoptees of ReasonML, much larger than OCaml adopters. All ReasonML is an alternative syntax for OCaml. That's literally all it is. So syntax matters. Syntax matters a lot more than I think those of us who are interested in programming language design as a hobby, if you will, tend to appreciate. You know, we design syntax for ourselves. We like it. This maps nicely to the semantics of the language. Great, it's great. I like it. Um, that's not going to help a newcomer to functional programming or a newcomer to expressively powerful type systems. Look at TypeScript, for example. TypeScript has gotten huge adoption, absolutely huge adoption, and it's a very powerful type system. Kind of has to be because it's sitting on top of JavaScript.
Yep.
A lot of JavaScript idioms are not necessarily well suited to statically typed programming the way that OCaml or Scala or Haskell do statically typed programming. So TypeScript is a very powerful type system that has gotten huge adoption. I think there's an enormous lesson in there somewhere. I don't know quite how to articulate it, but I do think it's important.
To what degree do you think the success of TypeScript can be attributed to its syntax, and to what degree would you say the same for the practical aspects of TypeScript, which has been historically the hurdle of adding types to existing JavaScript libraries to be able to maintain interop and tooling and stuff?
Right.
How would you balance that? What's your feel on explaining the success of TypeScript in terms of one, the language structure itself, the syntax, and two, the tooling and the library ecosystem and how TypeScript fit into existing work?
Yeah. Yeah. Super important question. So the syntax of TypeScript, I do think it's not just syntax. I do think there's one thing that I miss in TypeScript, and that is pattern matching. So TypeScript, I think, did a very good job of essentially saying, well, we already had this ECMAScript standard, so there was already this contemplation of how JavaScript needed to evolve to support programming in the large better, basically, right? It's no longer just a language for little scripts on a web page. So what does that look like? How do you evolve this language to support programming in the large? So JavaScript was already headed in that direction with ECMAScript 5 and 6 and
Mhm.
all that stuff. So TypeScript had some advantage in starting with a base that was already headed in a particular direction with respect to syntax describing sort of upfront expectations, if you will, if you want to think about types as describing upfront expectations. So TypeScript ran with that, and I think ran with it well, with the explicit goal, as you say, that existing JavaScript would be valid TypeScript. I think that's unbelievably important. I think if they had just introduced a backward incompatible, statically typed language that happens to compile to JavaScript, well, those already existed, right? We already had PureScript and a few others that are escaping my memory right at the moment. So I think with respect to the syntax and even leaving out pattern matching, I think that was probably wise. I think that was probably key to adoption. And then being able to provide TypeScript types for existing JavaScript is absolutely critical to adoption. No question about it in my mind. That you were able to distribute type files, type description files for existing JavaScript libraries made all the difference in the world. And then to have the tooling like language server protocol support for TypeScript so that you could just open up your editor, pull up your existing JavaScript, and then essentially float these types down on top of it after the fact. Yeah, huge, just makes a huge difference in my opinion.
Very well executed strategy. and some strategic decisions were very well thought through, and the execution was stellar, which I
Yes.
think explains the success and the adoption of TypeScript to the
Mhm.
degree that it has uh, it has been historically, and it will probably continue to be. Now they will roll out a faster compiler. They wrote in Go, and they shook up uh, the front end
A lot of
world
people.
with this notion that a language shouldn't really be compiled in itself. If it's slow to compile, let's write in
Right.
something else. Why not?
Implement something else. Yeah.
Yeah, and to a certain degree, the success of Scala when it started out and when it started gaining traction can also be attributed to this compatibility with the JVM world, because Java libraries could very easily be integrated in Scala, even though the syntax was different and Scala was not just a backwards compatible Java with extra bells and whistles. The
Mm.
fact that Java libraries could seamlessly be integrated into a Scala project made it super easy for Java programmers to switch.
Yeah. Absolutely. Yeah. For those of us who started with Scala sort of early, like around 2.8, 2.7, or 2.8, that was critical. That was absolutely critical. It was the only way to get real work done. Now, I do think that by the time we got to about 2012, 2013, maybe, um, it was really time to start looking to Scala libraries first to sort of wean ourselves off the Java libraries, in the interest of taking better advantage of Scala as a whole language. Um, and Scala is an unbelievably powerful language. It's one of the most powerful languages available. I mean, especially if you look at Scala 3, it's, I'm going to venture to say, the most popular dependently typed language in the industry. And that's
That's
saying
saying a
a
lot.
lot.
That's saying a
Yeah.
lot.
Yeah.
Do you have any ideas for how to make Scala 3 a truly mainstream language? I've been thinking about this quite a lot. I've been thinking about this for at least a year.
Mhm.
And it surprises me that so few people know about Scala, so few people have invested half a weekend on Scala just to try it out. Because
Right.
I guess if they did, they would understand how readable it is, even without the complex monadic, purely
Right.
functional stuff and the intricate things that Scala is still very capable of. Just like the plain language with the essential features, it's a super powerful language. You can get a lot done. Even like basic scripts, even a small startup in 2 days, you can. Especially in the age
Right.
of AI, if you get the
Yeah.
structure right and you prompt the AI, you can get some
Right.
very powerful code very quickly.
Yeah.
Do you have any ideas on how to make Scala more successful or more widely adopted?
I know the Scala Center is trying, and I really appreciate what they've done with Scala CLI and Corsair and just simplifying the whole installation process to get going. Um, I think there's a challenge, and I don't know whether it's the Scala Center's challenge or it's ours, honestly. But the problem with having a high abstraction ceiling in the language is ultimately it's inevitable that you're going to get multiple ecosystems in the same language, but that are essentially distinct from each other. So in Scala, we have, for those who might prefer as close to a Python-like experience as possible, Lee Howey's
Mhm.
ecosystem, which is a really great, you know, I keep talking about taste, high taste ecosystem. He uses a lot of sophisticated features of Scala to present these very simple APIs that are very simple to use. So a lot of that implementation complexity in the library is not exposed to the user, right? I think that's so important. I think it's so important to not necessarily expose the implementation complexity of your library in your API. Your job is to make it simple to use your API, right? How to generalize that across the board for Scala, I don't know. But again, Scala is right now a huge experimental test bed, if you will, for things like direct style effect systems. So instead of having the monadic ecosystem, as we do with cats or as we do with Zio even, we have new systems like Kio, which is
Hmm.
very interesting, Ox. So there seems to be a lot of recognition that syntactically and conceptually, these uh, more abstract higher kinded types, one example, um, present a barrier to entry for a lot of very smart, very hardworking developers. It's not that it's not that they're not capable. It's just that there is this ramp. There's this big ramp. Can we lower that ramp? A lot of people are trying in Scala. Everybody from Martin himself with Capri's coming down the pike somewhere, on down to direct style, Ox, Kio, other libraries that I'm forgetting. I think we have that responsibility, I have to say, in all honesty, and I'm a huge type level, cats, higher kind of types, great as far as I'm concerned. But I think we have that responsibility if we're not going to. I hate the idea of arbitrarily excluding somebody from enjoying this language. I hate the idea of arbitrarily excluding somebody from being able to work on high quality, high performance, scalable, safe software because they have to learn monads, because they have to learn Kleislis, because they have to learn, you know, all these
Yeah, it would
crazy
be a
terms.
huge loss. Yeah.
Yeah,
I
it's like more people should be able to do this than seem to be able to at the moment. And I do think those of us who develop languages, libraries, all that sort of thing, have a responsibility to address them. I do believe that. I don't know how. I
yeah.
didn't answer your question, but I hope we can come up with a way.
Yeah. I'm certainly trying to do that to flatten that learning curve. I'm also working on some materials on Howie's libraries to
Mhm.
make Scala more approachable and practical and get people going really quickly with
Mhm.
just the basics of the language. Because as you said, Howie's libraries are dead simple. You can learn in half an hour. And
Right,
much of that complexity is hidden behind higher kind of types and implicits and a lot of magical stuff, macros even.
right.
But Howie does an amazing job of hiding those in the library implementation and keeping things super simple, super explicit, almost
Yep,
Python style, but with the safety of a type
right,
system and with the guarantees that the language provides.
right. Yeah, which reminds me, I suggest that you have John Pretty on to talk about his new collection of libraries for Scala 3, Soundness. I
I
think
saw he
he's,
was working on a lot of libraries.
yeah.
He pretty much built the entire ecosystem from scratch. I don't know how complete that is and how.
Uh, yeah, yeah. But he's clearly pushed hard down whatever path he's identified.
I wanted to touch upon this notion that you've alluded to twice in this conversation. So you said something about taste. Once when you were speaking about your experience with the Red Book Scala Heroes,
Mhm.
and now when you are separating these ecosystem, each one with its own style,
Mhm.
taste is something that I've seen uh, experts talk about.
Mhm.
And people like Rick Rubin, when he's listening to a lot of music, he develops something that is very particular to him that allows him to find artists, diamonds in the rough, like Adele and Ed Sheeran and
Mhm.
whatever, and propel them to an amazing
Right.
level of success. So, my question to you is as an expert with so many decades of experience, how does one develop good taste?
How do you develop taste? And honestly, I think that parallels, again, referring to other arts. To me, the identical question, framed in other contexts, it tends to be expressed as, how do you develop intuition?
Hmm.
Uh, and I honestly think it's the same question. I think that mm, there's a challenge in seeking out examples. And I think seeking out examples is the only way to do it, which is why I suppose having decades of experience becomes important.
What do you mean
uh,
by seeking out examples?
so yeah, so I already talked about HTTP4S as a
Hmm.
great example of good architecture in the cats and cats effect in FS2, the type level
Hmm.
ecosystem, because it recognizes very explicitly that, as we discussed, that a handler for an HTTP request is a potentially failing effectful function from request to response. And that's what the type signature says in HTTP4S. It's very direct, it's very explicit, but it required a kind of pulling back from thinking of thinking of dealing with a web request imperatively. So now, of course, you'll expect that from the expert functional programmers who developed HTTP4S.
Hmm.
But there are other functional HTTP libraries in Scala and in other languages that are, to me, not as direct and clear in expressing fundamentally what an HTTP service is. So I think of HTTP4S as exactly the kind of example of taste, good
Hmm.
taste, that we're trying to help other people achieve. So, so when I think of looking at examples, I would offer HTTP4S as an example in Scala with the type level ecosystem. There was a unfortunately unsuccessful version control system, distributed version control system in C++ called Monotone, written by Graydon Hoare, the guy who wrote Rust.
Hmm.
Um, and I use it as an example of, boy, this is really, you're not going to believe these words coming out of my mouth. This is really beautiful C++,
Yep. Yep.
you know? And it's like, is that even possible? Beautiful C++?
I can empathize that. Although C++ is a bit is something that I've historically stayed away from because, frankly, I wasn't really adept at it, and I shot myself into it way too many times for me to give it another shot. But
Yeah.
I can understand that.
Yeah. Yeah. I think so. So there's a circularity problem here. There's a feedback loop problem here, right? Because it's easy to say, look for good examples, but you have to have taste in order to identify what's a good example. So I think there's no alternative other than to say, what do you look for when you look at a code base? And I suppose if I had to articulate one sort of overriding guiding principle for me, it's how easily can I understand a given code base both in the small and in the large? And that really gets to why I prefer functional programming, because in my mind, the easiest way to bridge the gap from understanding a code base in the small, looking at a particular function, looking at a particular method, to looking at the program as a whole is by composition. If you can look at a given expression and see what it means, and then lean on that understanding to look at a larger expression that uses that little expression that you just understood, to understand the larger expression, then I think A, the path to understanding is shorter. And I almost identify taste with having a short path to understanding, I guess.
Short path.
So,
Short path to understanding is a good answer. How would people? I mean, I guess I'm asking for uh, people coming into the industry as well as for myself. I am only starting to develop my own experience, my own real experience in the industry.
mhm.
I even with 10 years in the industry, I still consider myself much of a beginner. Um, so
Oh,
I'm asking for other people as much as for myself. How would you advise people like me or people like beginners to develop good taste or to find tasteful um software that can permeate their mind, if that makes any sense? So
yeah.
establish a good mental model of what intuitively is good code.
Mhm. Yeah. Well, boy, I don't know. Problem, I think, for myself trying to answer that is I can't claim to have beginner's mind at this point, right? So to try to make it an explicit discipline is extremely challenging. That said, see, all the answers that come immediately to mind are just are sound bites.
Is apprenticeship a good way to do that? So just to stay next to an expert and
Mhm.
kind of intuitively absorb what they think is good?
Yeah, yeah, I certainly believe I've benefited from patient mentors my entire life, not just in my career. But certainly that, certainly when I look back, especially on that Intel Media and Verizon Labs experience, I mean, I was literally pairing with Runar Bjarnason on Funnel for 9 months every
Hmm.
day. So, boy, talk about a formative experience, Yes, find smart friends, um, and be willing to ask what feel like stupid questions. I think I'm probably the reigning champion of asking stupid questions.
I I will give you a good run for your money on that.
But that's so this goes to comfort, right? This goes to when you establish a mentoring relationship as the mentee, in particular, but it goes both ways. Um, it's important to be intellectually and I will say even emotionally and psychologically comfortable in
Hmm.
that relationship because otherwise you're not going to ask stupid questions,
Yeah, you're
you
going to
know?
be afraid that somebody's going to chastise you.
Right. So it's important to be comfortable in that relationship. And then the sky's the limit. I mean, you can accomplish an amazing amount of stuff just by being willing to say, boy, I'm really sorry, but what you said just went right over my head. And
Hmm.
can we slow down and maybe back up a step and dig in a little deeper, if you don't mind, for my benefit. And then the next thing you know, there's that moment, and people have other than me have talked about this a lot. There's that moment when you suddenly understand monads. Now, as I think Graydon Hoare himself put it, the problem is once you understand monads, you immediately become unable to explain them to anybody else. And it's true. I've tried, believe me.
I
Uh,
have no less than 3 monad tutorials on my Rock the JVM YouTube channel, so I completely understand that.
yeah. So, but something like that happens, and that's just, monads are one example, but there are dozens and dozens and dozens in different aspects of writing software. All of a sudden, you'll have this flash of insight. And that's the point of the exercise. That's what you're trying to accomplish. But a flash of insight is subjective, is inherently subjective. At a certain level of intensity, you might also even experience it as a religious experience. You know, something has now defined how you think about what you do as a career or what you like to do with your spare time, even as a hobby.
Yep.
Um, something that grabs your attention and won't let go. And in a previous conversation with James Ward and Bruce Eckel on Happy Path Programming, I said the technical term for this is obsession. Um,
It
it
kind of
is.
is. It won't let go. Once you've had it, I mean,
Right.
everybody who's understood monads, it has probably had a sort of obsession to see the world differently in the way that they cannot unsee monads once they've seen them, really.
Right. Right. And you asked earlier about what are contexts in which I would be unwilling not to use purely functional programming or
Hmm.
Scala or whatever. And it's very much like that. You're asking me to give up the ability to reason about my code algebraically. Good luck. Why would I do that? Why would I even consider it? I 99.9% of the time I know what my code is going to do before it runs. Why would I give that up?
That's a
Under what circumstances would I give that up? Um, some of this, I have to say honestly, on a personal note, probably also reflects the fact that I studied physics as well as computer
same.
science. So there is that element of the universe is deterministic, setting
Mathematically and described mathematically.
right, setting quantum mechanics aside, right, setting the Copenhagen
Yep.
interpretation of quantum
Even
aside.
that is mathematically describable.
Right, right. The Schrodinger's equation is rigidly deterministic.
Mm-hmm.
So here we are. We're as developers, I think a lot of the time we're asked to accept the proposition that that machine over there, that hunk of highly refined beach sand, is out to get us, is going to subvert us, is going to misbehave, is going to be unpredictable. We can't know what this hunk of highly refined beach sand is going to do. I don't get that perspective. I don't understand that perspective. John von Neumann famously, many moons ago, said, anyone who considers arithmetic means of generating random digits is, of course, in a state of sin. um, and that's true. The only, in order to get a random number out of a computer, you need a source of randomness going into the computer.
Yep.
That's why we use pseudo-random number generators. Or if we want real randomness, it has to come from the decay rate of a cesium atom or somebody typing on the keyboard and moving the mouse around a lot. If you ever generated a private public key pair with GPG, you probably went through that exercise. Randomness has to come from someplace else. Most randomness in computing comes from right here.
Yeah. And just because you don't understand it, that doesn't mean it's random. And
right.
this is definitely the case of the AI spitting out a lot of things that we don't really understand where they come from. I mean, we're kind of trying to reverse engineer how on earth are they so good, or how on I mean, they're good and bad to certain degrees, and we can talk about this in more detail. But the fact that they seem to be spitting out things that surprise us. Let's use that term. It's surprising. The output is surprising. Just because the output seems surprising, it doesn't make it random. You just don't understand it.
Right. Yeah. Yeah. And that's a really great example. It reminds me of a question that a reporter, I think, asked Bertrand Russell back in the early 20th century about logic and axiomatic systems. Right around, must have been around the time that Russell and Whitehead wrote Principia Mathematica. Right? And Russell had made the point that basically all theorems necessarily follow from the axioms by the rules of whatever formal system, whatever logic you're using. And a very clever, I think, insightful journalist asked him, well, does that mean that theorems never tell us anything new? And if so, why do we sometimes find ourselves surprised by a proof? And Russell acknowledged the point and made the point that I think you're making, which is that, yes, there can be an element of psychological surprise. There's something about the human perception or the human apprehension of a chain of reasoning that the result can be surprising. But it is true that there's no new information given in going back to axioms and theorems. There's no new information in a theorem, in the result of a proof. It's true. There's no new information there. All the information is already contained in the axioms and the rules of inference. So what? As a human matter, I think it's important, I think it's significant that we do find ourselves surprised by these results. Computers can surprise us, proofs can surprise us. Now, when a computer does something we didn't want it to do, that's an unpleasant surprise, and I think it's fair to ask how that happened, right?
And it's worth understanding just...
Yes, and preventing in the future, depending upon, here we go again, how much it costs to prevent it.
Yep.
Right? That's where we are. And by the way, I want to be very clear about this being a heavy-duty type theory, formal verification kind of guy. It is an economic decision. It is a business decision, how much time and energy to put into doing these kinds of verification and understanding upfront Sometimes you have a tough business call to make to let something out the door that you don't completely understand. Maybe it has known bugs. I was at Apple Computer when we shipped System 7.0 with over 1,500 known bugs. None of them were data loss causing. That was the criteria for shipping, for letting the thing out the door. But there were over 1,500 known bugs in System 7.0 when we shipped it.
Does do you? That's an interesting point. Um, where would you make that call to not use a heavy duty effects system or formal verification system or functional style thinking
Mhm.
to be able to ship code faster and accepting the fact that you can cause trouble along the way? I mean, not necessarily critical trouble, but some trouble.
Yeah, yeah, right. Well, to go back, like I observed earlier, that we consumers have the benefits of protection from the credit card companies with respect to invalid charges or things like that. So actually, almost anything I would say, maybe with some regrets, in B2C software as a service, if you're not dealing with if you're not using an automated payments automated clearinghouse type of system, if you're not dealing with transactions that are not covered by the consumer protections of a credit card company, then you have a surprising, I think, amount of latitude. Doesn't mean you get to be lazy or neglectful or whatever the case may be. It just means that I would be more comfortable saying I don't immediately know what reducing this expression is going to do necessarily. It could misbehave. I'm still going to use things like the saga pattern. I'm still going to try to ensure that a multi-stage workflow that can fail at stage 6 is going to successfully undo the previous stages. I'm going to do my due diligence, right?
Mm-hmm. And it makes
Um,
sense.
yeah, but I might not be quite so insistent about I want my managed effects. I want my failures or errors represented as values with a particular type. Still, that would still be my preference, but some of that comes down to familiarity. How low cost can I make applying these tools? Well, with a decade's experience in the type level ecosystem, I can probably rapidly build a pretty reliable system with the type level ecosystem. So maybe the cost isn't that high for me and a team of people like me. But if the question is general about, how can we, under what conditions can we say, let's hire people who aren't experts at the type level ecosystem or the ZO ecosystem, or what have you, then I think a lot of business to consumer software as a service is reasonable to do with other approaches.
Yeah,
To be
this is
honest,
one of the hurdles in the Scala ecosystem is that companies generally complain that they find it hard to recruit experts, and they
Mhm.
only recruit experts because they've probably seen something that you've described, which is that you can get a productive team to work on a safe, powerful system very quickly only when they have the necessary knowledge and taste and experience, and
Mhm.
those people are hard to find. I would argue that they're hard to find in any domain, really. So if you want to hire expert Python developers that know libraries inside and out and have their types in their head, and
Yeah,
they can produce similarly powerful software because they know the ins and outs of the libraries and tools that you're using, that's similarly hard to do.
yeah. Yeah, ecosystem matters a lot. And I think it's important to talk about ecosystem and not just a particular library, a particular language. It's a whole culture and again, especially with a multi-paradigm language like Scala or C++ for that matter, there are multiple cultures centered around a particular school of thought, a particular collection of libraries, a particular collection of books. When I did C++ professionally, I was also notorious because I was very much in favor of using the Boost libraries,
Mm.
which are sort of the cats and cats
Yep.
effect of the C++
I remember
world.
those. Yeah.
So, so there were C with classes was how Boost people described that opposing subculture in C++.
Hmm.
The C with classes people were aghast at the Boost architecture astronauts over here. So, I think that says something about both the power and the danger of multi-paradigm languages. That multi-paradigm languages have multiple subcultures of course, of necessity, and those subcultures generally hate each other. It's, I think, an
Yeah, I
unfortunate.
mean, there's usually a conflict because these subcultures probably want to shape the direction of the entire thing, and they want to
Mhm.
shape it in the direction that
Right,
they find preferable.
right.
Have you seen in your career languages or libraries or tools that have aged well or stayed relevant without um getting on the race for features and
Mm.
uh, this never-ending strive to make libraries and tools more feature complete and uh, in this endeavor more complex? Have you seen any tools that have stayed relevant uh,
Hmm.
across time?
OCaml.
OCaml.
Yeah. Head and shoulders. OCaml, I mean, obviously not mainstream, but remarkably consistent. Famously, Jane Street
Yep.
uses it for high frequency trading. Head and Shoulders is the most obvious example. OCaml has evolved very deliberately. It's almost surprising, and I think with a different mindset, maybe even to some people disappointing, how slowly it evolves. And I don't know whether that's because they have a major industrial user, even though it came out of, it was developed to develop the coq, or now rock, proof assistant, the French proof assistant. Um, but here it is being used by a major industry player. And I suspect, I certainly don't know for a fact, that helps govern its stability, relative stability over time. The OCaml team don't add features for the sake of adding features. They tend to do so to solve a specific problem. So they improved the compiler optimizations with a system called fLambda sometime in the 4.x timeframe. And now OCaml 5 is out, excuse me, with an algebraic effect system,
Hmm.
sort of its headline feature. Um, I think partially because there started to be some bifurcation in the OCaml 4 user base between a monadic effect system called LWT, lightweight threads,
Hmm.
and Jane Street's own async or core and async libraries. And it's sort of like, okay, you have to choose one of these ecosystems again. And I think that was perceived in certain circles as undesirable, that having multiple disjoint library ecosystems in OCaml was not a good thing for OCaml. Plus, the design, the theory behind effect systems had evolved to the point where I think the OCaml team said, okay, we can take a stand here. We can implement an algebraic effect system according to a particular theory, according to a particular approach to doing that. And they did. And now library developers are taking, their LWT code or their async code, and now there's an OCaml 5 library called EIO, which is based on the new effect system. And so there's kind of what you would hope for. There's kind of a unification or a merging of what used to be different teams working on more or less the same thing, possibly overlapping, if not at cross purposes. And now it tends to be sort of converging and focusing on this unified approach to the problem. So yeah, OCaml impresses me for its governance and stability over time.
Why isn't OCaml more mainstream, do you think?
Well, gosh, because it's not C or C++ plus plus or Java. I, it's I think there are a lot of lessons that should be taken from OCaml, and I think TypeScript takes quite a few lessons from OCaml. In particular, thinking about row types and polymorphic variants. I mentioned ReasonML earlier, I think.
Hmm.
I think if I had to recommend a language for people to new programmers to pick up and try to be productive with today, that would be really pleasant to use, high productivity, usable on both the back end and the front end, um, and with really, really good library support. And now I'm thinking of Reason React in particular for front end work. I would say ReasonML, which is just
ReasonML.
an
Okay.
alternative. Yeah, which is again important lesson.
Hmm.
Syntax is important. ReasonML looks a lot like TypeScript or ECMAScript, except with pattern matching and some other things that
Hmm.
TypeScript lacks. Um, but you can compile it for the back end, you can compile it for the front end. There are libraries for both. Um, yeah, if I had to start today from scratch, I would probably be using ReasonML.
That's interesting. What would you tell to a? I mean, just to continue on that, what would you tell a young programmer that's coming out of university, or I don't know, a beginner version of yourself with the wisdom, but without the knowledge itself? So without the knowledge of the various programming languages and tools that you've seen in your career, but with the wisdom and taste that you've acquired, like the implicit one, the intuition.
Yeah.
What
Right.
would you tell this person when they're starting out to build good skill in programming?
Focus on paradigms, not languages.
Okay.
So, I have sort of a short list of paradigmatic, if you will,
Mm-hmm.
languages that I think represent each. So, spend and it takes time. I think if you study computer science in the university, you probably take some language survey course where you have a project in 3 or 4 different languages, maybe 5 different languages, and each of these projects is maybe a couple of weeks long or something like that. That's frankly not enough, especially if you're really talking about different paradigms. So, you know, develop something in Smalltalk because Smalltalk is the paradigmatic object-oriented programming language. Develop something in Prolog because Prolog is the
Mm-hmm.
paradigmatic logic programming language. Develop something in Haskell because Haskell is the paradigmatic functional programming language. Develop something in C++. Plus plus. Well, maybe not C++. Plus plus. Develop because it's multi-paradigm. Develop something in C or Go or Zig, but pick a systems programming language and develop something in it.
Rust, maybe, or
Pick
is
a
it? Or you would avoid Rust because it's a bit multi paradigm.
Also because it introduces quite a few features that I think would be a distraction from what's the essence of a systems programming language, you know. So I guess I'm also recommending a kind of minimalism
Mm-hmm.
with
So
respect to
isolation of a certain style of thought, rather.
yeah,
Mm-hmm.
yeah, that's a good way to put it. Yeah, Rust is a great language. If someone were to say to me, Paul, write a Linux device driver, I would almost certainly do it in Rust.
Mm-hmm.
Um, but in terms of exposure to a paradigm, in terms of exposure to a school of thought, I think Rust has forces you to attend to a few too many things that aren't really necessarily about this is what it means to be a systems programming language.
Mm-hmm.
So from that point of view, I personally might choose Zig. for that. Or Odin looks like another strong contender. But something or even C, if the idea is to experience a systems programming language, whether you think it's necessarily the best systems programming language today or not is a different question.
Mm-hmm.
But any of those I think would be suitable. Rust is self-consciously an alternative to C++. That's a great goal, and I think Rust executes on it really well. But that's a bit much. So I might not recommend Rust as an exposure to the idea entry for the same reason that I pulled back from recommending C++.
I see. Okay. And how would you balance that with the desire for a young programmer to be exposed to a well-adopted industrial language? And the reason I'm asking this is because I used to hold labs in university, and one complaint that even I, as a student, had while going through university, and even my lab students used to give me that when I was holding labs, is why do we care about Haskell? Because nobody writes Haskell,
Right.
Or it's less popular or less industrially adopted. They wanted to learn like the big five, like the JavaScript, TypeScript,
Right.
Java, Python, that sort of thing. But
Yep.
we had courses in Python where we use them for very specific purposes rather than getting them ready to write production quality software in Java or Spring or whatever. We never really focused on any one of these libraries, and we were all asking, myself as a student when I was a student
Right.
a while back, and my own students when I was holding labs, why are we not studying these very industrially adopted languages? Because we want to be fit for software engineering jobs. Why do we have to learn about Haskell and Prolog and Scheme and whatever else?
Right.
How would you balance the importance of trying out various paradigms with the desire of students to be well prepared for the industry directly in a well adopted industrial language?
Yeah. Yeah, and that's the eternal question, has been for decades, for good reasons. Students are correct if their intention is to actually write software for a living. They're quite right to observe that computer science is one discipline, software engineering is another discipline. And if the intention upon graduation is to do software engineering for a living, it would help to learn software engineering. So I sympathize. I would say the connection is very much the same as the connection between, let's say, going back to physics, the relationship between classical mechanics and civil engineering. If you want to go out and build things, physical things, buildings, bridges, all that sort of stuff for a living, yeah, you need to learn about concrete and steel and all the tools and techniques that you need in order to accomplish that as a professional, as a civil engineer. Those all rest on the foundation of classical mechanics. If you build a structure a certain way with certain materials, it will collapse.
Mm-hmm.
It won't be sound. And famously, of course, there's the old film of the Tacoma Narrows Bridge literally twisting in the wind and collapsing, right? Famous example. I would say it's the same with computer science and software engineering. The reason to attend to different programming paradigms is really twofold. One is so that when faced with the great opportunity that hopefully you'll have at some point in your career to choose what language and libraries and so forth you use on a particular project, you'll be well informed with respect to which of them is best suited to solving the problem in front of you. And it's not necessarily the mainstream ones, but it might be. Conversely, if you're put in a position where you are not given the choice of what language and libraries to use, or maybe some latitude with respect to the libraries at least, but not the language, and the problem is set out in front of you, then you can at least identify what architecture, what library choices, what combination of capabilities, technical capabilities, is going to be best suited to solving the problem in front of you. a concrete example of that is I would prefer not to use Java again if I didn't
Mm.
have to. But if I did have to, there are great reactive programming libraries like Project Reactor, like Mutiny, good integrations into Spring and Quarkus and the other major Java application frameworks. So if you are a functional programmer and you tend to treat almost every problem as a effectful streaming problem, if
Hmm.
you use S2 a lot, which I do,
Interesting.
then, if you wind up in dealing with Java, as long as you have access to Project Reactor or Mutiny or one of the other really good reactive manifesto libraries, you might not, you might not feel quite so bad as you otherwise might. But you wouldn't know that if you didn't have that exposure to streaming effectful programming from some other paradigm or some other ecosystem.
Did you have so I feel this whole discussion on uh, having a broad exposure to different paradigms so you can make informed and wise choices. That's what wisdom essentially means.
Mhm.
Um, did you have any sort of eureka moments or pivot points in your career that made you feel enlightened in a way? So, uh,
Absolutely.
famously, the monad understanding is one such experience for many functional programmers. Did you have? Uh, can you give any examples of such pivot points or such eureka moments in your career when you
Yeah.
felt enlightened to this degree?
Yeah. Yeah. I think the first one, not really the first one, but a key one was still at Intel Media
Mm.
slash
That
Verizon.
must have been a very formative experience.
Huge. It was my first. So it was so long ago that we were actually using Scala Z
Oh
at the
wow.
time.
Okay.
Cats didn't exist yet.
Yep.
Working on the knobs configuration system, one of knobs features was that first of all, it supported multiple sources of configuration, everything from config files to Zookeeper for
Hmm.
distributed configuration, things like that. And one of the sort of headline features that it supported was dynamic reconfiguration for sources that were capable of providing it, which is not all sources. But for sources that were capable of providing it, you could, for example, change the config file on the file system, and that configuration would take effect throughout the running program without having to stop and restart the program.
Hmm.
And this took advantage of a new feature at the time, Java 7, if you can imagine how long ago that was. But there was a new API for file watching, for watching the file system
I think they
dynamically.
they had the Neo thing at that time, right?
The NIO,
Yeah,
right?
the NIO.
Yep,
Hmm.
non-blocking IO
Yep.
system. So they used that to provide an API for watching files directories for
Yep.
changes. So we took advantage of that new feature in starting as of Java 7, so that if you made a change to a config file in a running application, that configuration would take effect immediately. Well, how does that work? I mean, how do you propagate the change from the configuration file throughout everything that cares about the configuration, right? And the answer to that question is, well, you construct at the time, Scala Z stream, today would be FS2, right?
Hmm.
You construct a stream of the configuration values. And so the only time you see a new item in the stream is when the configuration has changed.
Hmm. And you update your state accordingly.
Yeah, right. So the joker in the deck is your program has to be referentially transparent for that to work. If there's anything that's kind of hanging on statefully to the configuration somewhere, then of course it won't see that change coming down the stream. But if your entire application is built on this notion of The way we know what the configuration is because we got a new instance of it or value of it from the stream, and the rest of your program is consistent about working that way, then you can do that kind of thing. So that was a major aha moment for me in terms of really wrapping my head around the importance of referential transparency, that this isn't just some theoretical abstract concept that functional programmers like and make a big deal about. If you're in a big enterprise environment like Intel Media or Verizon Labs and you can't afford to stop and start a service when the configuration changes, then there's a lot of practical value to streams and dynamically updatable configuration.
And it acts like a forcing function um, to think your code in a certain way, rather
Exactly.
than just go the academic route and just imagine some nice pieces working together seamlessly in tandem. You have a real use case that you have to that you have to make work.
Right. Right. I like to point out to people that it's not an accident that Disney streaming services uses
Cast
the type
effect.
level
Yeah.
system. It's not an accident that Comcast uses the type level ecosystem. Um, it's almost as if the bigger and harder your operational requirements are for a piece of software, the more value there is in these crazy theoretical abstract
Hmm.
concepts.
Did you, for many programmers, this sort of decision to embark on this journey of pure functional programming and referential transparency and all these nice concepts
Mhm.
um, may seem risky because they see a steep learning curve, they see very few positions. Obviously,
Right.
in important roles, like as you mentioned, in things like finance or um, things that are not allowed to fail badly, or that if they fail, they can recover safely and reliably.
Right.
These positions seem generally rare,
Mhm.
and it seems like a long way to exceed to that position, which is why, even talking from my own students, uh, seeing that thing seems very far away, and so the journey to that seems very risky.
Right.
Um, I have maybe two flavors of the same question, but they sound like two different questions. You can take any which one you want. Uh,
Okay.
did you take any risks like that in your career, and
Mhm.
uh, how what led to that? So that's
Yeah.
one side, and the second
Mhm.
side of that question is how would you advise other people to embark on that journey, if you would advise them to go that way?
Yeah. Well, ultimately, the answer to that question comes from your conversation with James.
Hmm.
Um, this has to get easier and cheaper. It just does. Um, so rather than asking how we can elevate the industry, the participants in the industry, to being able to develop um, automotive braking systems or avionics or
Important
you
code.
know
Hmm.
yeah, finance, financial transaction, reliable software. I think the question is really how do we make it cheaper and faster to not necessarily reach, but at least much more closely approach those levels of reliability for the software that we develop as line of business every day for any domain, any industry. Why do we tolerate? Again, I keep using the example of being protected by the credit card companies on reverse charges and so on and so forth. But why should we have to lean on that and related similar kinds of mechanisms so much when software misbehaves? Why does software misbehave so much, in the first place? Why again, as a physicist, the question I always ask is, why do we take these rigidly deterministic devices and let them behave in surprising ways, to go back to our earlier conversation? Why do we tolerate surprises from these rigidly deterministic devices.
Probably
Uh,
because I would add a potential answer to that is because of short term uh, gratification of spewing up a little piece of software and it just works, but you haven't thought it through and you haven't thought
yeah,
about edge cases, and the edge cases aren't really that bad, which is why this vibe coding
they
thing even
aren't
exists, really.
exactly. It's back to the business and economic question. If you can get 90% correct functionality and the remaining 10% misbehaving functionality is not catastrophic, however you define catastrophic, then that's a great position to be in 90% reliability, and nothing goes so horribly wrong that you lose customers, somebody dies, you go out of business. Nothing anywhere near that catastrophic, right? That's a huge category of software that I think people like me, people who like strong type systems, sound type systems, functional programming, I think we have to acknowledge that that's a legitimate place to land as a business proposition, right? Which is another reason why I think the answer to the question is to make it cheaper and faster to do better.
To do
Because
reliable software.
yeah, if the business is doing okay with the current state of the art, or not even the current state of the art, but rather the current mainstream, then what are we supposed to say about that? We can't blame them for making the rational business decision to accept a 10% failure rate that isn't catastrophic, right? So what do we want? Well, we want a better experience for the users. We want to take more pleasure in our work. We want to take more pride in the artifact that we're putting out there before the entire world. So I also think we have to be honest about that. I think we have to be honest that there is an element of pride,
Hmm.
personal pride and professional pride involved in doing a good job. Are we doing the best job we can possibly do? If all we're doing is meeting the minimum business requirements of not going out of business and not losing customers and all that sort of stuff, that's okay. There's nothing morally wrong with that. I think a lot of us who write software, who choose to write software every day, especially those of us who did it as a hobby before it became a career, I don't think that satisfies a matter of personal pride or professional pride. So if we want to satisfy that itch, if we want to scratch that itch, we have to make it cheaper and faster. Otherwise, the business will tell us to take a hike, and they'll be right to.
Yeah, that makes sense. And it explains some of the business decisions that other people and other companies have indeed made with respect to these tools. Because as we were talking about type systems and functional programming and effect systems and stuff, many companies choose not to use them because they find, justifiably or not, but they made a business decision or a business case out of that they don't want to embark on that journey because it's tough for them,
Right.
and it may be justifiable. But I have to ask, um, due to this tendency to spit out a little code and it just works because we have so many powerful tools, how do you feel the current LLMs and AI have influenced this game with all the vibe coding and stuff? Do you
Yeah.
feel that software is becoming more fragile because of it? Do you believe that if people, there are different arguments out there on the internet. Some people believe that software is becoming more fragile and we're gonna die because of the AIs, but not necessarily because the AIs are gonna take over. It's because we're gonna make a catastrophic mistake.
We're just
Um,
going to
just
do
we're gonna
software.
just vibe code our way into a
Yeah.
cancer treatment or whatever.
Right.
Um, or other people would say that because there are so many more coders out there, naturally we will evolve to safer software just because there's an influx of new ideas. How do you see this? How do you see this evolution?
I can't really respond to the big picture aspect of the question. What is the outcome going to look like? What does strike me, and I feel more confident offering an opinion about, is the idea that LLMs, because they train on publicly available sources, benefit from things being explicit, right? Things being lexically apparent, things being readable, straight from the source code. So from that point of view, what occurs to me, and this is still an opinion, obviously, it's not an observable fact, but it seems to me likely that LLMs will benefit from training on not just purely functional code where effects are values, errors are values, everything is a value, and they're all subject to some algebra. But even more specifically, from the monadic approach where you're taking advantage of higher kinded types, you have types that are parameterized by type constructors. That's as explicit as it gets, right? When you look at a piece of Scala code in tagless final style, and it says right there, we have some type constructor f that takes one argument, and it is constrained to be an async, or it's constrained to be a monad, or it's constrained to be this, that, or the other thing. That's an explicit declaration in the source code as to what that f can do. It can do anything an async can do. It can do anything a monad can do. So the more LLMs train on that, the more likely it seems to me that when you ask them to produce code that is going to do X, Y, or Z, they're going to do it correctly because the code that they've trained on is so explicit about what it can and can't do, which is kind of the whole point of purely functional programming, typed purely functional programming in the first place. So typed purely functional programming seems like a great training resource for LLMs. Will that drive either the adoption of typed purely functional programming, or conversely, will the adoption of LLMs, both directions. Will the adoption of LLMs drive the adoption of typed purely functional programming, or will people start to pay more attention to typed functional programming as it exists because of LLMs, and then possibly start using LLMs for their purely functional programming because that symbiotic bidirectional relationship is successful? I don't know. I haven't spent nearly enough time exploring LLMs, to be honest. I think it's one of those things that's going to come up for me out of necessity.
Yeah.
Or too much more time goes by.
I will add some thoughts here because I am using LLMs with a little Scala product that I'm building, and I happen to use the type level ecosystem. And it is the case that when I lay out the structure and when I ask the LLM to produce a bunch of code that respects that structure, that code is pretty much like 99% of what I would write if I had the whole day to do it. And and that certainly adds to the productivity aspect to an already safe structure. So the aspect of safety and convenience, if you have a lot of safety, you generally trade it off for productivity, speed, convenience, and that sort of stuff because you have so much ceremony. But now with LLMs, you get a vast cost reduction in that because once you lay out a structure, you can potentially produce very powerful code very quickly with the mental model that you initially imbued it with. What about how do you feel about the other people that do not adhere to this style? And I'm talking about the JavaScripts and the Pythons and the easy to produce vibe coded games and web apps and SaaSes and stuff. How do you feel about those?
Well, to the extent that LLMs train on publicly available code, the good news is that probably by the time even Python code or other dynamically typed systems and languages, by the time that code shows up publicly, it probably works reasonably well. So I'm not actually as nervous about LLMs and less rigorously typed code than some other people might be. That said, I would feel like LLM produced dynamically typed code would need a particularly good testing framework or testing regimen to have a lot of confidence in it. And the problem with that is one that Amanda Graham now, And I identified in our presentation back in 2012,
Mm-hmm.
types versus tests
Mm-hmm.
at Strange Loop. Um, Tests can't replace types because tests, you can't have an infinite number of test cases. Let's put it that way. So there's always a level of how much testing is enough, right? You always have that question. And I think you have that question even more so, it seems to me, if you have LLM generated dynamically typed code that you have to test. Um, so I think that's the sticking point for me with respect to LLM generated dynamically typed code. It feels to me, again, not based on any particular experience, but just intuitively, it feels to me like it would introduce a significant testing burden. And I wonder whether that testing burden wouldn't outweigh the productivity gains of having the LLM write the code in the first place.
That's an interesting point, because uh, LLMs are being touted as this incredibly productive tools or productivity enhancing tools to the degree that many companies have laid off a bunch of developers because, for economic reasons, they made the decision that fewer developers aided by AIs, is just enough for them. Um, but I wonder, and we're probably going to see over the next few years, I guess, um, how that how those cost deductions in their mind actually fare against the LLM generated code and the extra burden that you're mentioning. And I
Yeah.
have to ask this. I don't know, the question that everybody keeps asking over the past uh, even past couple of years already, and you're probably going to roll your eyes on it. Uh, our AI is going to take our jobs.
Uh, well, I keep leaning back and then go out of frame. Um, yes and no. I mean, it sounds like a cop out, but I think there's a range of what humans are currently developing in software that can be completely automated. And I don't know what to say about that. Um, but I think you already answered the other part of the question in the sense that AI can be a big productivity boost. You've described a productivity boost for yourself, developing type level ecosystem code with AI assistance. And what occurs to me, if you take the slogan seriously, that the goal is if it compiles, it works, then the closer we get to that, let's obviously that's some sort of ideal that probably will never actually be met. But we can approach it. I think that's the point of types purely functional programming. We can approach it. The more we can approach it, then the more confidence we can have and the more relaxed we can be about using AI to assist us in developing that code because we let the LLM produce the code, we compile it. If it compiles, it works.
Hmm.
Uh, Modulo whatever gap remains in achieving that ideal. So you want to be the human in the loop. And then the question becomes, well, what kind of human should be in the loop? When, sitting between the LLM generated code and being correct. And now we're just circling back to the question of wisdom and taste. Right?
How do people? I mean, um, I wanted to ask a follow up question to it, and you already answered it. And the question was, what kind of humans are still going to remain in the combo between software engineers and AI? And you kind of answered it with the software engineers with good taste, good understanding, good a breadth of mental models,
Mhm.
and solid understanding of them, which is, in a word, wisdom or taste.
Right.
Uh, and On the other hand, a lot of software companies do not hire juniors for this reason because they intuitively understand this. and they want experienced engineers guide the AIs because they have the necessary skills, experience, insight, wisdom, knowledge of tools and stuff, so that they can understand the code that the AI is producing, and they cannot rely on juniors to do it. So the
Right.
question is, how can a junior accede to that sort of level? Are we stuck with the the senior developers that we still have, or the people that are soon to become seniors? How do we breach that conundrum?
Yeah. Um, I think this problem existed even before LLMs were on the scene, in the sense that I know a lot of uh, less senior developers, especially in the Scala community, have observed this phenomenon that all the roles that are available seem to be for seniors. Um, I think I can't think of a way, let's put it that way. I can't think of a way to get around the necessity for less experienced colleagues to, I hate to say this, I really hate to say this because it's just a complete slap in the face to the whole work-life balance issue, but I don't see a way other than spending your own time, evenings, weekends, um, exploring and improving or increasing your exposure. So, I talked earlier, we talked earlier about paradigmatic languages
Mm-hmm.
and learning paradigms. Um, Extend that thought to learning fundamental data structures and algorithms, learning particular libraries for the particular language that you happen to be using at that particular time. So what is that? What's another way to put that might have might be a little more succinct? I think you have to alternate. First of all, you have to be self-learning. That's all there is to that. You have to be a self-guided learner. What's the strategy? What's the learning strategy that seems to me you have to adopt? I would say it's an alternating breadth first, and then going deep when you encounter a specific need for a particular language or a particular ecosystem, particular library. So try to acquire a multi-paradigm level of knowledge about an inch deep. Um, your goal is to learn enough that when called upon to learn something more specific, more detailed, you know where to start. So touch on different languages, different paradigms, different architectures, different design principles. And then when faced with a particular problem in a particular language, in a particular ecosystem, you know what websites, what books, what podcasts, what courses that you now have some notes, keeping track of that you need to do a deep dive on. So technically, I think that's iterative deepening search, I think is the is the actual technical term for that strategy.
Are there any particular spikes that you would recommend people start with first in that search? Because there are better and worse spikes to spend your time on, and time is limited. Everybody has the same 24 hours in a day. And
Yep.
as you were talking about work-life balance, everybody's circumstance is different, and so they may
Right.
have their time budget limited.
Yep.
So
Different constraints.
yes,
Yeah.
and so what I wanted to ask is, do you recommend any particular spikes that would help the most
Mhm.
in elevating or in broadening somebody's mental scope?
Yeah, actually. Um, I think the community that has done the best job of providing very general, but nevertheless presenting lots of opportunities to do a deep dive in software engineering is the domain-driven design community.
Mm, interesting.
So I would strongly recommend going to the source, Eric Evans' domain-driven design
Hmm.
book first. And then Von Vernon has done a great job of taking the principles from Evans and talking more specifically about well, one of his books is How to Implement
Mm.
Implementing Domain-Driven Design. So hands-on, how do you approach some of these principles from domain-driven design? And then for those of us in functional programming, and especially those of us who tend to think of all systems as ultimately being streams of events and responding to events. So event sourcing. Event sourcing obviously comes from the domain-driven design community. It's just that functional programmers tend to do that as a first class kind of explicit sort of thing with our streaming libraries and ecosystems. So from there, I would say Scott, I'm going to terribly butcher his name, Scott Wolachin, um, uh, domain modeling made functional, I think is his book,
Okay.
which is written for F Sharp, which is a underappreciated language in the .NET ecosystem, essentially OCaml for the .NET ecosystem, but applies to every functional language that you can name. So, I would say start with domain-driven design, especially focus on what the DDD community calls the ubiquitous language. Get your stakeholders all using the same terminology, the same way. And when you write code, explicitly express the domain concepts as entities. So when you're reading the source code, it's using the same terminology as the business owner.
Mm.
That's, I mean, the most obvious launching off point that I can think of. It almost transcends the question of paradigm and language and ecosystem and all that sort of thing. Not quite. I still lean in recommending domain modeling made functional. It's like, okay, this is where these important concepts, this is where the golden spike in the Transcontinental Railroad is in my mind. But you want to do that. You want to. Functional programmers talk about programming with algebras all the time. What do those algebras represent? What are they manipulating? That's where domain-driven design actually comes in and answers those questions.
This is fascinating. And it all ties to the same intuitive concepts that we've essentially formalized in the functional programming domain, which essentially guarantees good abstractions. What to come back to what James Ward said in my previous conversation, good abstractions, which is why he focused so much on effect-oriented programming. And this also ties into what you're describing with domain-driven design, and it circles back to our themes with functional programming and algebraic modeling. They all are various facets of the same school of thought, the same mode of thinking around good software.
Yeah. Yeah. And again, for me, and I guess for you too, informed by a background in physics, we had to extend our notions of what an algebra is.
Yep.
When we studied physics, if we studied physics. And it turns out that thinking about software, the minute you define software as getting a computer to do what you want it to do and preventing it from doing what you don't want it to do, then all of a sudden it seems to me, and again, that's a prejudiced observation coming from a physics background, it almost seems to me like you have no choice but to talk about algebra. Because what is an algebra? An algebra is a set of entities in a context and a set of operations on those entities. Anything that isn't one of those entities, anything that isn't one of those operations on those entities, can't happen, right? Shouldn't happen, shouldn't be allowed to happen. So it falls out naturally, it seems to me, to say, once you know what your domain is, and you can model that domain as an algebra, or more than one algebra, collections of entities with certain kinds of operations allowed on them. Again, very prejudiced way to put it. How else would you do it? Why wouldn't you do it that way? What would you accomplish by doing it some other way.
Would
Well, it might be more familiar to somebody without a mathematics or physics background. But would it accomplish the goals of the system more successfully? And I think that's the question we always have to come back to. And here's where I wind up sounding probably most elitist. I wonder if we don't worry excessively about making writing software approachable rather than worrying about making the systems we build work correctly.
and software isn't. I tend to agree to this take because as software is eating the world, it
Right.
becomes increasingly important to eat the world correctly, to eat the world well,
Right.
rather than swallow us whole.
Yeah. You hope it's constructive, right? I mean, human beings are exceedingly interesting animals because we can take raw materials, dirt, water, various minerals, and refine them and put them together in a way that at least locally reduces entropy, does something constructive, does something useful, improves the lot of our kind, animal kind, you name it. Hopefully, we have the same attitude towards software. We're not using girders and, beams and what all else from the physical world, but we're building something. We're building something that hopefully, at least locally, reduces entropy, does something constructive, does something useful. In order to do that, you have to know what you're doing. Now, again, the right way to approach this is to make it cheap and easy to do the right thing. Right?
Yep.
So that's my anti-elitist response to my own elitist impulse to say, yeah, your system should work. Okay, can we just establish a baseline that your system should work? Okay, how do we achieve that without making it a requirement that you have some sort of advanced degree or what have you? I think that's a legitimate question.
Do you see just to turn the conversation a little bit towards the future and maybe set this as a to as a point on which we can start to wrap up our conversation? Do you see any particular tools or languages or ecosystems that are executing this idea particularly well, in the sense that they're making correct software easier to write or cheaper or more approachable? So
Yeah,
maintaining correctness, but
right.
bringing it a little bit more down to earth.
Well, you would ask me the leading question right as we're at time, because I will literally spend an hour talking about this, and I literally will spend an hour talking about this.
Then it's a good reason for a round two.
Yeah, exactly. Well, let me, if you'll forgive me, take the opportunity to offer a commercial for my presentation coming up at LambdaConf in May. I'll be talking about Epic Games Verse programming language, which I think is the answer to your question. So it's interesting to have a programming language come out of probably the biggest game engine development studio in the world, the folks behind the Unreal Engine, which powers Fortnite and many, 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 many other titles.
Many of everybody's favorite games.
Yeah, everybody's favorite games. So Verse comes out of Epic Games' experience over the last 30 years and more, having developed Unreal Script for the first version of the Unreal Engine that powered titles in Unreal Engines 1 through 3, and then having developed a visual programming language called Blueprints, node-based data flow programming language that really increased its power in Unreal Engine 4, and a lot of titles have been developed with Blueprints. But Blueprints starts to show its limitations in terms of turning into sort of visual spaghetti, the more complex programs in it get. So the crew at Epic Games are developing a new programming language very much oriented towards everything from first-time programmers who've never written anything that could be reasonably called a program in their entire lives, to experts who develop things like the Unreal Engine for a living. It's very, very ambitious. And what they've done, I think, which is very wise, is they've implemented a subset of the language that thousands and thousands and thousands of new programmers are using right now, in the Unreal Editor for Fortnite, UEFM, have been using it for over a year to develop gadgets for Fortnite worlds, Fortnite islands. But it's a subset of the language. The full language is a very technically ambitious language. It's a logic functional programming language. It's inspired by a couple languages that nobody's ever heard of, Ontic and Icon. You can see influences from existing logic functional languages like Curry in it as well. But then it all is heavily focused towards this can't scare people off. So the syntax can't scare people off. The semantics can't scare people off. It needs to be as intuitive as it can possibly be, given that scope, everything from a first-time programmer to an expert. That's obviously ambitious. So I've spent a lot of time researching its influences, which I just described a couple of, or named a couple of, didn't really describe them. But that's what I'll be talking about in another month, roughly.
Nice.
So if you'll forgive the commercial for LambdaConf, feel free to edit this part out.
I will not. I will invite everybody to come to LambdaConf and watch you deliver this presentation, because this is going to hopefully get you some insight into other styles of thinking, and hopefully get new inspiration for making the complex stuff that sounds or seems scary, and make that easy, and make that approachable.
Yeah. Yeah, I hope they're successful. I hope Epic is successful with this. It's a huge over 2 decade in Tim Sweeney's thinking about it. I should also point out that he hired Simon Peyton-Jones away from Microsoft Research to work on this, and Leonard Augustin. So some of the functional programming heavyweights that that we know are now working on Verse, which I hope bodes well for its potential success.
Nice. All right. Well, Paul, it's been a privilege. I very much enjoyed this conversation. Time flew by for me.
Yeah, but it was mine.
And before we wrap up the conversation, is there anything that you would like to share with my audience? A thought, a question, a quip, or a piece of advice, anything that comes to mind?
Well, once again, if I could take advantage of your generosity a bit, I will point out that I am looking for new opportunities at the moment. So if any of this sounds like anything that would be helpful to an organization who might have a architect or staff or a principal engineering role, I'd be interested in talking. And more generally, I'd say, reflecting back on sort of the beginning of the conversation about how there's been a proliferation of languages that have appeared over the last several years, it's a very exciting time to be doing what we're doing. And I think I think it's easy to get so lost in being heads down and writing code and doing the day job and all that sort of thing, that it's easy to fall into the trap of not stopping and smelling the roses and saying, this is a great time to be writing software. There are so many areas, back to software is increasingly important and increasingly important domains. There is so much to do, and there is so much that's being done. And it's just a very exciting time right now. Yeah, maybe there's a little market uncertainty. Maybe it's not clear, if you don't have that much experience, how to get that experience, or what technologies to focus on, how to gain that senior status, all that kind of stuff. And those challenges are real. In the meantime, let's try to have some fun with it.
Awesome. That is an amazing way to wrap the conversation. Let's have some fun with it. Paul, it's been a pleasure. I'm looking forward to a round two because we have a lot more to discuss. And
Oh,
where can people find you on the interwebs?
yeah, that's a good question. I have a badly neglected blog on GitHub pages. So my GitHub handle is Paul-Snively. That's probably the best way. I'm trying to remember now if I put my email address on my poor neglected blog, but send me a message on GitHub, I think is probably the best way.
Okay, so we'll leave a link in the description for you to contact Paul. He has more wisdom per minute than almost everybody that I've ever met. And so it would be a very wise decision to hire him. And until next time, folks, thank you for listening, and I'll catch you up soon. Thank you, Paul.
Thanks, Daniel.